Doug Robbins is MITRE, and he's responsible for setting strategy and priorities to ensure MITRE delivers technical capabilities in support of Air Force mission objectives. But I was looking at his bio. I'm not going to read the whole thing, but something I found really important that hits home is he established a rapid prototyping department dedicated to delivering innovative solutions to MITRE's warfighting customers. I think that's most important, especially in today's world where we need things qualitatively and rapidly delivered to our warfighters. And I thank you for that. And Doug, you're up.
Thank you, Nino, and good morning. It's great to help kick off day 2 of the conference, and it's my pleasure to introduce our first keynote speaker of the day, Brigadier General Chance Saltzman. He is the Director of Operations and Deputy Chief of Staff for Operations Headquarters, U.S. Air Force. The directorate encompasses 5 divisions: the Air Force Operations Group and the Air Force Flight Standards Agency. It's responsible for policy, guidance, and oversight for Air Force current operations for airspace and cyber. Provides real-time or time-sensitive SA to Air Force senior leaders to enable global vigilance, reach, and power. He's not a stranger to the area, graduated from Boston University and was commissioned in 1991. He has operational experience in space and missile systems with the Minuteman III. He was a Minuteman III launch officer and a satellite control operator at the National Reconnaissance Organization. He was both a graduate and served as an instructor at the U.S. Air Force Weapons School at Nellis Air Force Base. And after graduating from there, was assigned to the Joint Space Operations Center, where it's the Chief of Plans and then later the Chief of Combat Operations. After that, he's commanded in squadron and group wing levels, including the 614th Space Operations Squadron, the 1st Space Control Squadron at Vandenberg, the 460th Operations Group at Buckley, and as the commander of the Aerospace Data Facility in Colorado. I think many of those, or if not all of them, a core to what they're doing is multi-domain operations and multi-domain C2. So in 2016, the Air Force tapped General Saltzman to be the point man for one of the chief's top 3 priorities, and that is multi-domain command and control. And today, we're happy to have him here to talk about that work that he and the ECCT team did in multi-domain command and control, and where the U.S. Air Force stands with that today. So, ladies and gentlemen, please join me in welcoming Brigadier General Saltzman. Thank you.
Well, thank you. It's a real honor to be here this morning to share some thoughts. You heard I'm a Boston University graduate, and I'll tell you this: there are probably some professors somewhere, maybe they're retired, it was a long time ago, but they would laugh one of those deep guttural laughs if they knew I was asked to come here and explain anything to MITRE. My academic record does not support this kind of honor, so I appreciate the time. I'm a space guy. You probably heard that loud and clear through the bio there, but the task that I was given by the chief is multi-domain command and control. So it's been an interesting journey to take my space background and my command and control background at the JSPOC and broaden that out to an Air Force perspective. And what does it mean to do multi-domain operations and command and control for multi-domain operations? So that's really what I want to kind of spend some time with you today talking about is, let's broaden this out. Let's make sure we understand exactly what we mean when we say multi-domain operations and then the command and control of those multi-domain operations. And I think there's some important nuances that are worth capturing for this audience. And so I appreciate the time today to do that. So as you heard, the chief gave me this task, and this is how I kind of captured what it was he was asking me to do. He said, look, we think multi-domain command and control is really going to be the key to future warfare. We're going to have a lot of data. We're going to have the ability to create effects. Are we going to have the C2 structures necessary to employ those effects in time and place of our choosing at an ops tempo that we'll need to be successful in future war. And so that's what he was concerned about. And my task was basically to organize his thoughts around what multi-domain ops and multi-domain command and control is. And so, you know, we kind of went down and said, well, are you just looking at the technical aspects of this, or is there more to it than that? And so he was pretty clear that, no, I want to see the material solutions, but also the non-material solutions. And we found a lot of areas that required non-material shifts, and not the least of those is going to drive some cultural changes for the Air Force, how we view our operations. And so that's been another important aspect of this. So this is what we got right out of the gate. Hey, aren't we already doing multi-domain operations? You know, if you could go back to the Doolittle Raiders and say, when you're launching bombers off an aircraft carrier, that's multi-domain operations. And you know what? I think we're right. I think that's true. The Army has had combined operation or combined arms as kind of a tenet of their operations, where they use aviation assets to complement the ground. And so I don't argue that we are not already doing multi-domain operations. What I'm arguing is that I'm trying to use that term in a more specific context. And the analogy that I've used in the past is like air-land battle. Air-land battle, it was a specific construct that we developed with the Army in the Cold War timeframe. It wasn't a generic term of reference for how an Air Force and an Army works together. It was a specific construct that had specific tenets and specific design elements that brought that combined arms effect together. And so what I'm proposing, and I'll show you some examples, I'm proposing that multi-domain operations be considered as a specific construct. And specifically, we're currently operating in multiple domains, but we're not really taking full advantage. And you can see some of the challenges listed here. That primarily we're just talking about surging, pulling planners together for a discrete operation, not as a matter of course to be continuously operating as a multi-domain force. The stakeholders associated with airspace and cyber are dispersed, disconnected to some degree, and there are complicated relationships. Those that are more familiar with space operations, if I said satellite communications and who's responsible for defending satellite communications to ensure that those capabilities are continuously provided to the warfighter. If you started listing the agencies, the command and control structures necessary, it would make the case of how complex and complicated these structures really are. And they kind of work against us when we start talking about seamless, rapid integration of capabilities. And so that becomes really what we're trying to do here is resolve some of those complexities. At the bottom here, I say that if we start thinking about not just operations in multiple domains, this is not a GPS tail kit on a JDAM. Okay, that's not multi-domain operations. This is not just using ISR data collected from space to support an air campaign. Those are all necessary, but not sufficient to get to where we want to go with multi-domain operations. We have to think about generating independently in these domains offensive and defensive effects in order to create those dilemmas for an adversary. And just to hit that point again, it's more than systems in one domain supporting operations in another domain. That's necessary, but not sufficient. Okay, the Army has a huge Air Force that supports the ground campaign. That's a combined arms approach, and that is certainly operating in multiple domains, but it's not multi-domain ops the way we're designing it. Multi-domain ops has to be characterized by high velocity, operationally agile operations. We know that we are gonna have to create effects across regions, globally, but still regionally. We're still going to deal with multiple combatant commanders, whether you think about space through STRATCOM, cyber through U.S. Cyber Command, the air components through a regional component, a regional command. Talking to General Harigian at Al Udeid, he'll be the first to tell you that he relies on UCOM assets and PACOM assets to do his mission in CENTCOM. So even if you say I'm a regional combatant commander, you require the assets and capabilities of other regional combatant commanders. Well, what's the C2 structure that's going to make this operate seamlessly? Shifting between commands, shifting between domains, so that we can continuously create these dilemmas for an adversary. And I think the answer is multi-domain command and control. We have to have a command and control system and structure that allows us to seamlessly shift and be continuous in operations. As we started to do the analysis on what is it that multi-domain ops needs to overcome, a few things jump right out, and this won't surprise this audience. Any connection to the intelligence community will show you that these things are true. That future conflicts are probably going to be decided by the side with an information advantage. Interesting, you know, because the hardcore warfighters in us that wear the uniform always want to say, hey, if you bring capacity to bear, if you break enough stuff, you're going to come out on top. And you know what? We're just not necessarily seeing that play out on a linear scale the way we anticipated. And what we think is we start talking about peer adversaries that we're likely to face in the future, that's going to be less and less true. It's not about the side that can bring the most capacity to bear, break the most things. It might be the ones that find exactly the right thing to break or the exact right pressure point. And that's going to be about information advantage. We're going to be in an environment where we almost know everything, or at least have the capacity to know everything. But will we have the ability to sort out the wheat from the chaff and make decisions at an operationally relevant tempo? And I think that becomes really the essence of the command and control problem set. Right now, though, we don't really have a command and control structure that supports that kind of operations. And our gap analysis, when we went through this, said, you know, that our actual operational constructs are not designed to optimize command and control across multiple domains. It's designed to support space or air or cyber. It's not designed to comprehensively integrate those capabilities to achieve synergistic effects. That's just not the design. So we need to start addressing that, and I'll walk through some examples in more detail there. Our technology, we've got tremendous technologies. We've got tremendous sensors. We collect unbelievable, vast amounts of information, but we're still not leveraging the technologies that really I would consider just state of the world right now. Whether it's machine learning and just basic automation, whether it's data sharing through virtualized structure, whether it's information assurance using modern security techniques in the digital environment, we're not taking advantage of that largely because we don't have an architecture or the policies in place that allow us to take advantage of it. And so that becomes a line of effort that we have to address. And then finally are the support structures. And for the military planners in the audience, anybody with those experience, this would be the rest of the .mil PF, right? There's the policy, the guidance, the facilities, the infrastructure, all of those things that we have to consider. When we really looked across the gap analysis doing this, we started to focus on two primary areas: training and education, and in the policy, and primarily policy associated with security. Those became the biggest elements of these support structures that weren't really in place to foster multi-domain operations the way we intended. And I'll explain that in a little more detail. So again, I'm not trying to put too fine a point on this, but it's important to me that we get away from the general applications of these terms and we start talking specifically about what we mean. And so multi-domain command and control is just an enabler that allows us to effectively conduct multi-domain operations. All right, so those are kind of two separate aspects of the same premise. But to do the multi-domain command and control, there are some structural changes that we have to put in place. And I mentioned a few, but we have to have the right enabling policies. We have to have more access to larger data sets across different platform sensors and decision makers. Therefore, we have to have that network that enables that. We have to understand the basic concepts for warfighting in a multi-domain framework. And again, I'm going to go into a little more detail on that because this is an important one. But we currently have space constructs, we have cyber constructs and air constructs, but we haven't really thought about how they come together in terms of multi-domain warfighting constructs. We don't train people to be multi-domain experts. We train people to be space experts or air experts. And really, in the air, you train people to be airlift experts or tanking experts or air superiority experts. And so the idea that there's some lieutenant colonel out there that can sit down in his planning cell and build a multi-domain campaign plan, we don't train or educate people along those lines to be able to do that. So those people are hard to find. And really, if you do find them, it was really luck of the draw and a career path that gave some exposures. It wasn't deliberately planned to create those. We've got work to do there. I mentioned the infrastructure and the tools. We certainly know that there's technology that can help us make faster decisions. We just don't have an architecture that allows us to rapidly test and integrate them on a timeline that makes them operationally relevant. And so we got work to do there. The way the team has broken up this challenge is along 3 lines of effort, and it just corresponds directly to those categories of challenges that we face. Operational concepts, the technology, and lastly, the enabling structures. And again, I'm going to show you an example where we're focused on training and education with the development of an operational C2 cadre. But this becomes kind of the structure, if you will, that allows us to perpetually optimize high velocity, operationally agile operations. And that word perpetually is specifically chosen because I want to contend that the journey here is part of the process. This is not about, I'll deliver a ConOps to the chief and he'll sign it and we'll be good to go for multi-domain operations. There is no technology that if I just survey enough of industry, I will find the technology that enables multi-domain operations. This is not about the product. There is not an answer here. We have to establish processes that continually refine this rapidly. And once we have that process in place, I know we have the operational experts, and I know we have the industry support, we have the academic support, we certainly have FFRDC support to enable this to rapidly be enhanced over time. And so it's about process, not product. That's an important piece. So now I want to kind of put you in this mindset again to explain multi-domain operations. And so the example I've chosen is just a classic mission of the Air Force, suppression of enemy air defenses. We all know how this works. You fly into the denied area that's thick with an integrated air defense system. And currently we use air assets to either jam or wait till they light up their radars, and we use anti-radiation missiles to try to target them, blow those capabilities up, drive them autonomously. This is a well-known doctrine that the Air Force has employed. Likewise, our adversaries have paid attention to our capability to dismantle IADs and have made those IADs that much better. The standoff distances, the rings keep getting bigger on the map. The resiliency they build into them have become tougher and tougher. And so, against a peer competitor, this mission set will be tough. But we are developing capabilities to continue to provide counters to the anti-area access denial capabilities through air, space, and cyber. And so don't think support to those traditional air missions. Think independently achieving effects against an IADS from space, independently achieving effects through cyber that starts to dismantle that IADS. We are pursuing those capabilities. So once we have the ability to conduct this mission from those different domains with the capabilities, how do we see to it? And what are the challenges with C2ing it? Who's the seed package commander when you're executing air, space, and cyber? Are we going to rely on just traditional support relationships with STRATCOM, Cyber Command for some regional air component? If so, who's going to write that establishing directive? Multi-domain tasking cycles. The targeting cycles alone would require, right now, 3 combatant commands to agree on placing those targets on the right list. Not an inconsequential thing when you talk about the battle rhythms of 3 COCOMs across maybe 12 to 16 different time zones trying to orchestrate that. We've talked about battle management in the air for a long time. The work that the E3 guys do and the JSTARS guys do to direct aircraft to the time and place where they need to be. Now, what's battle management look like for cyber operations? What's battle management look like for space operations? How do we dynamically adjust when you're a part of a seed package supporting a kinetic effect? And this goes even to the full extent that says, what about space superiority? We've talked about, as airmen, we've talked about the prerequisite of establishing air superiority to effectively enable surface forces. It really isn't debated much anymore. If you don't have air superiority, your maneuverability on the ground is substantially degraded. Well, now let's start taking that up the altitude. Is space superiority a prerequisite for air superiority or a continuation of maneuver on the surface? Against a peer adversary, they're gonna create complications using space assets for us and deny areas because of their use of space assets. So are we prepared from a C2 standpoint to fight for space superiority before we can start to enable air and ground maneuver? These are just some of the complications we know we have to work out. So let's dive in a little bit to some of the operational constructs. We've been contesting the air for 100 years now. And over those 100 years, we've learned some things. In that left-hand column, our doctrine reflects how we structure, the mechanics that we structure to do air superiority and achieve the air effects we need in a campaign. We know we provide an air component commander to a joint force commander. That commander is usually triple-hatted. They are both the area air defense commander, the airspace control authority, and they usually wear that joint air component commander hat, the JFAC hat, to synchronize those efforts. These are kind of known mechanics that we use to contest the air. The main vehicle is the Air Operations Center, and even inside that Air Operations Center, to make sure that we're comprehensively accounting for all the right things, we have liaisons, we have the Director of Space Forces, now we have a Director of Cyber Forces. The Army invests a huge amount of people into our Air Operations Center in the Battlefield Coordination Detachment to make sure that air capability is synergistically linked to the ground campaign. We've learned that over time, that these mechanics are necessary to contest the air. But if you build the analogous columns here for space and cyber, in blue, I offer you analogs that are not described anywhere in our doctrine. If you need an area air defense commander, do you also need a space defense commander or a cyber defense commander? Is that an important hat to wear where it's consciously, deliberately called out? Is there an equivalent to the airspace control order for space? And I call it orbital control authority because space control authority has different connotations in satellite command and control. But orbital control authority, think about it. The reason we have an airspace control authority is to establish the rules of the road for effective, safe operations in the air environment. We don't want our planes running into each other. But more importantly, once you establish the rules of the road, it rapidly allows you to identify hostile acts. If somebody's behaving in a way counter to the rule set, you instantly know that they're a threat, and you can address whether they're hostile, and you can engage them. Standard airspace control authority processes. Now let's think about that from an orbit standpoint. How close can two satellites get when tensions are high before it's considered a hostile act? What are the rules of the road? How do you determine two satellites approaching each other and it's benign or it's hostile? What are the threshold considerations that need to be applied? Do we have the situational awareness to be able to do it? From a space defense commander standpoint, who's responsible for the critical asset list, the defended asset list? Is it the regional commander who has to rely on those capabilities? Or is it STRATCOM who has the broader responsibility to defend all of the assets on orbit? And if there's a contention between the defended assets list, because you can only defend so much, do we have to take all those decisions to the SecDef because that's the first common superior commander? Is that an operational model that's going to work for us? So this is just commenting on the fact that now that we've declared space and cyber as warfighting domains, we've got to rapidly mature the mechanics associated with contesting these domains. I think there's lessons to be learned from the air side. We'd be foolish not to take advantage of these lessons and just apply them and see what works and doesn't work. See what we like, see what's not feasible because the domain has different characteristics that we need to address differently. So one of the ways that we're going to try to tackle this is we're going to establish an annual war game specifically focused on these kinds of issues. Where the focus is multi-domain operations, multi-domain command and control. And what we're going to do is we're going to do the first one this fall. The players in the war game are going to be War College and ACSC students, Air Command and Staff College students. So think majors and lieutenant colonels primarily that are not working in their primary jobs, but rather have taken a year off to get some education. And so the hope is that they won't be bogged down in their day-to-day, they won't bring their day-to-day baggage from their jobs with them. They'll be able to think more broadly about this in an academic sense and start to talk about some of the problems, challenges, issues associated with moving forward in terms of a multi-domain construct. So we're going to conduct our first one of these in October with the class that comes in this fall. And then we're just going to learn the lessons and try to apply them. So let me shift real quick to the technology side of things. This chart basically leverages the traditional observe, orient, decide, and act, the OODA loop, and says, well, let's make sure we're thinking about command and control from a data-centric standpoint. And this is a shift in our thinking because traditionally C2 has been thought about in terms of effects-based operations. What is the effect you're trying to achieve? What's the capacity and capability you have to achieve that effect? And how do you give that capability the guidance and direction it needs to achieve that effect in time and place? So we think platforms and we think effects when we do C2. And the contention is that if we go back to the premise about it's the side with an information advantage that's going to be able to direct those forces more appropriately, then we really need to be thinking about C2 from a data standpoint. How do we manage the information that's going to be available to us so that we can achieve a strategic advantage through decision speed? And so I've kind of laid on top of the OODA loop here those kind of key areas. We're still going to have to collect data. We're still going to have to figure out where does it live, how is it managed, how is it exploited, what are the capabilities we use there that will enable that C2 structure around the OODA loop. But in our gap analysis, you instantly see problems with our current structures. We put data through feeds and it's all in stovepipes. If you're the space operator at an AOC and you want access to a ground moving target indicator data from JSTARS, it's almost impossible to get it in your system. It just doesn't happen. Because of the way we architect it, the way we build around data feeds, our data is trapped in these stovepipes. Once it's trapped in the stovepipes, it becomes very hard to really take advantage of artificial intelligence and machine learning because you don't have universal access to enough of the data. You're trapped in just whatever the feed is that can come into that AI algorithm. Multiple formats of our data. The security policy. We have firewall issues where there's access to information right here, but there's a firewall that separates us and I can't get between the two just for policy considerations. We have to address that. Our interfaces, the way we design our systems, we don't really impose a set of common standards for interfaces and messaging and data. So you're free to build a sensor. You're free to build the data links that's supported in the Fusion engines as a stovepipe. We need to get past that. So there's common interfaces. So any sensor can be linked to our virtual network and be immediately contributing across a host of data sets. I'm not going to read all of them to you because I know they won't surprise anybody in this audience, but there are substantial issues, to say the least, with the way we manage our data in support of multi-domain operations. So on the left is just a cartoon, and again, I recognize I'm talking to some technical experts here, so it's not intended to be an insult. You know, this is big clip art cloud in the middle. That's the way all data structures are envisioned, right? You got to start there. And the universal symbols for databases are those nice cylinders and files, et cetera. So the idea, though, is if you just read the list of characteristics, when we have universal access to that data, total global connectivity from the most disadvantaged bandwidth user to the high-end AOCs. At ADFC, the number of data feeds I had coming in, the number of servers I had at my disposal, amazing. But you can't replicate that to a two-ship of aircraft in a contested environment at the edge. So how do we manage that global connectivity? How do we make sure this is interoperable? And I don't mean that just from an Air Force standpoint, because we have problems with our own interoperability, aircraft sharing information between each other. But now you add the joint services and interoperable challenges there. You add coalition capability, there are interoperable challenges there. And what we're learning in terms of space and cyber and special operations in particular is that there are other countries that are bringing better capability, better authorities, and better data that we need than we have. But we can't always take advantage of it in a universal way because we're not interoperable to share that information. And then lastly, this is going to be a center of gravity for us, which means the adversary is going to try to take it out. And so we have to have a highly resilient architecture and data structure that enables us to keep going even despite adversaries' intents. So again, it's kind of a cartoon. The ability to plug in sensors and producers, plug in customers, and universally access this information is going to be important. And as we did our gap analysis, we started to center around 6 challenges to that vision: security, latency, the data access, bandwidth considerations, network management, and think resiliency there. How do you continue to manage your network as it's under attack? And standards, common standards for interface, messaging, data. These are not particular to any specific program. And you see some of the initiatives we have there listed, you probably recognize most of them, that are attempting to improve our C2 capabilities. And each of them encounters those 6 challenges every time they try to do anything. But they're coming up with independent solutions to solve their particular problem set. This is the way we do acquisition. You give a program manager requirements, and they try to tackle them with the resources you allocate. So if data access is a problem for whatever the JSTARS follow-on is, they will come up with advanced battle management data access solution, and they will employ it to meet their requirements. That same solution may also work for the DCGS infrastructure, the CMCC architecture, the next gen AOC, but those program managers will not know about it because we do not incentivize this enterprise approach to sharing solutions and meeting requirements. And so if there's a tech banner to MDC2, it's about enterprise approach. We want to experiment, collect data that directly solves these enterprise challenges that apply to all the programs, because the program managers themselves are not incentivized to do it. And maybe rightfully so. This is not a critique on acquisition. It's just these are big problems, and a program manager's got to solve, the 5-meter target rather than looking across the enterprise all the time. So we owe them that, and that's one of the things that MDC2 is going to try to do. So our mechanism to do that, we're calling the shadow network. And it's really just a network of DevOps environments. And I know that's a popular term these days to talk about agile acquisition and DevOps environment, but it's about time that the government kind of goes kicking and screaming into the mid-90s and figures this out. How we do this fast, how we adopt software, how we test it more rapidly, how do we make it operationally available to the warfighters as quickly as possible to get their revisions. And so we're going to set up this network of DevOps environments and build experimentation that specifically goes after those 6 primary challenges. And I've listed there kind of what our initial focus is. How do we share information? What's that architecture that really can be? It's the palette, right? We want the architecture to kind of be there across all of our C2 nodes, so that it doesn't matter whether you're sitting at the JSPOC or National Space Defense Center or at Fort Meade. If there's data or a sensor that you need access to, because your infrastructure is standardized, you can get access to that data. We don't really have that architecture yet. It's still all about feeds. But we want to use live data. We want to rapidly get solutions into warfighters' hands and iterate with them on what the next best solutions are. And again, it's about those enterprise challenges. The network is really, like I said, it's a connection of these DevOps environments that are really already in existence. And I know Gordon Kordiak's here, and we talked about establishing, there's a second node in Colorado Springs, actually, that we hope to start to stitch together, add to this. But these are just people that are doing the right kind, they're asking the right kinds of questions, but they're doing it from their programmatic standpoint. And so what the shadow network does is stitches them together so we can draw enterprise conclusions on the work that they're doing. And then purpose build some experimentation that goes after those enterprise challenges. What is a faster way to test software so that we don't have to go through a 2-year cycle to test our software after it's been developed? Those kind of things. Okay, and then my last topic, and I know I'm running a little bit short on time here, but I talked about this training and education piece in terms of supporting structure. And one of the things that readily became available, or we became aware of, is the fact that at the operational level for command and control, we don't really have purpose-built experts to perform that function. We really treat it like a staff. We take experts in various operational fields, we pick them up, we drop them into an air operations center for usually 1 tour, and they do the best they can to do operational level C2, and then we send them back to their primary career fields. About 86% of people that do work in an AOC just do the one assignment, never to return again. It's a very small portion of people that have multiple tours in an AOC and get good at it. And this is art, not necessarily science. And so the exposure you have and the more experience you get in these systems is really what makes you more of the expert. And so you can't really just say, okay, we're going to send people to multiple tours to an AOC, because the way the Air Force works, we're very tribal. You know, the tribe that you're assimilated into as a second lieutenant from an officer standpoint is where your identity is. I'm a space guy. I said it when I first got up here, right? That's where, actually, I started as an ICBM guy, so I'm weird. But, you know, the idea is that whatever tribe you're in, that's who takes care of you. That's who sets you on the path for squadron command and group command. That's where your allegiance is. And so when you have to go do something outside of your tribe, you kind of feel a little uncomfortable. Like, hey, I need to get back so I can keep making my reputation there so I can get more opportunities. So in recognition of that, we've just decided we have to create a new tribe. And so that's the idea of this new AFSC that we're calling 13 Oscars. The difference here is it's a cross-flow AFSC, because operational experience is important to do operational C2. So, you know, you'll spend 10, 12 years in your accession career field, flying, satellites, cyber, what have you. And then a small portion will cross-flow, talking 50 officers a year maybe when we're in full sustainment, at the 9 to 12 year point. And for the remainder of their career, they'll do operational level C2 work. AOCs primarily, COMAFOR staffs, JTF staffs, COCOM staffs, or joint staff, anywhere where operational multi-domain operations and the C2 of multi-domain operations, anywhere where that skill set is needed, this would be the kind of officer that would be beneficial. Again, the ability to train multi-domain effects and the C2 of those effects in a way that we really don't have now because of our tactical emphasis, really. So this is a kind of a concept that's still emerging. We're still designing it. I'm hoping to get a decision later this month, in fact, to conduct the first board for crossflow by the end of the year and be kind of up and running next summer with our first group of people to crossflow over. My last slide. I kind of took advantage of the position I was given to do a little lecturing to 4-stars, and it really went about like you would think it would. Hey, thanks for your input. You know, it's really cute the way you see the world, Mr. 1-star, but you know, we understand this in great detail. But there's a message here, and I'm stealing General Goldfein's words, because you may have heard him in several speeches talk about that he doesn't want new old as much as he wants new. Right? Just the evolutionary, taking an old capability and just upgrading it is not going to be sufficient to get where we need to go for future capability. And he says, where are my new ideas? And I said, well, that's great. And it briefs well, and there's a good bumper sticker you can have, you know, in pursuit of new, right? But if you really look at how we design our systems, it's no surprise that you get new old, right? I mean, just look at it. When you say upgraded in capability, create something new, think of all the structure that's there to support you. Industry understands the mission, and they just want to make it a little better. Our CONOPS for how to use the system is already in place, well understood. We have standard operating procedure and expertise that's built around the old mission set, so simple enhancements are easy to assimilate. We are designed for new old. When you start talking about resourcing, this is much less risk. All the engineering work, all of the unknowns have been solved. So it looks like you're being good stewards with money. We're just making it better. We're taking a known thing and making it better. That's what the system likes to see. New, very different. The industrial base isn't always there to support it, right? The technical expertise, we don't have a CONOPS to support. The detail can be very low on those, which creates senior leaders being how are you going to use this? What's this for? What's the requirement set? Those are the words that know you're on ground to dive back over into new old when they start asking you those questions. Give me the CONOPS first, give me the detailed set of requirements, and then we'll talk about it. We just went back to new old. This looks like you're being a little entrepreneurial with your money. These are big ticket programs. But if you can't define the ConOps and the full set of requirements, it looks like you're just throwing money around. People don't like that in the Pentagon. They certainly don't like it over on the Hill. So there's just institutional inertia that prevents us from wholesale diving forward into a new approach. And I just call that out. I'm not saying one side is better than the other. What I want them to know is, hey, you can't just say, give me new. That's not a reasonable approach if you think about the way we structured to do this. Recognize that the system will naturally produce new old, and you've got to carve out different disruptive thinkers, different places where you can explore new, because the traditional system is just not inclined to give it to you. This is that cultural mindset that's difficult, it's hard, it puts people in uncomfortable positions. But if we really want to move forward on a grander MDC2 approach, we're going to have to, lose sight of the shore behind us a little bit and go into some uncharted waters to get after new. So that ends the lecture. I saw some head nods, so it was actually better received than when I talked to the 4-star. So thank you. But we got a lot of work to do, and it's going to take a team to do it. So thanks for your time, and I guess I can take a few questions if. Yes, sir.
That's an excellent upgrade. But I want to challenge you on 2 points. One is I saw your vignette, I think it was chart 8, that said 2030 implementation, and you talked about it being mostly process and training, non-material solutions. So that doesn't seem to jive with 2030. And then the second half of it is a lot of the things that you talked about, when you really get into it, process, timing, flow of command, multi-level security, formatting interfaces, structure of how you send data and how you parse who gets it and where it goes and all that kind of stuff. And I've done command and control satellites. It's a very slow, tedious, methodical process that there's a lot of mechanical things involved in it. So I would challenge you that there are a lot of material changes that need to be made as well as process. So it's mostly process, but there's a lot of material things, and those take time to change as well. So can you just address those?
I don't disagree with any of that. If this was easy and the road was clear, I probably wouldn't be here talking about it. But I think what I'd offer is once we establish what the vision looks like, and let's just talk the technology piece, first. If we do the right foundational design, I think we could spend the next 10 years really locking in place that foundational design, both policy and hardware and software, enterprise services, virtualized data, connecting multiple clouds together in a more usable way. How do we integrate test software rapidly? Once that foundation is in place, I think you could get to this vision fast. So, if we say, hey, you're 12 years out from 2030, that's not even 3 FIDEPs. That's pretty aggressive. I agree. But if we spent 10 years on the foundation, I bet in those last 2 years, we could get exactly where we want to be. My fear is that we jump right to the tools. We jump right to some answer and then try to lay it on top of our existing architecture. And then it just grinds the gears because the system is not designed to. There's a lot of great tools I see, a lot of great algorithms I see, opportunities to explore artificial intelligence and machine learning. We're jumping to the answer before the system is laid in place. I sometimes use the moonshot, literally the moonshot example as a case study. It's, hey, you have to go through Mercury and Gemini before you can start talking about Apollo, right? We have to figure out, how do you put a man in space and let him survive reentry and come back and pick him up in the ocean? You got to do that. In Gemini, you got to figure out how to do RPO and separate spacecraft and put them back together. You have to learn those operations because they're all fundamental to the Apollo program. We didn't just start building the Saturn V, putting 3 guys on top of it and start shooting them at the moon. There's a plan for this. We did that in less than 10, 15 years, if you think about it. And there were long lead items to the Apollo program. So while Mercury is going on, you're building the first gen engines for the Saturn V. Well, what are those long lead items? Virtual data structures, this common platform services and infrastructure services that we have to get after now as we learn operations like Space Defense Commander, the orbital control authorities. While we practice these concepts, we build those long lead items once we have this vision. So I think we can do it. We just have to do it in an organized approach and spend our money wisely all along the way. Yes, sir.
General, thanks for the presentation. Appreciate it. My question is, I know you probably are still working through your acquisition strategy on how you're going to get to your end state. Are you willing to operate along with the lines of using OTAs, leveraging commercial businesses practices and their tools and things to get things kick-started a little quicker than going through an acquisition process?
If I just say yes, can I stop? Yeah, absolutely. Agile acquisition almost demands that you do those things. And again, it's about how fast can we put products into warfighters' hands to refine them. I think the best way to do that is through OTAs, rapid prototyping, some of those traditionals. Now, if you're going to sustain this long term and have the right transparency for Congress so that they can continue to fund it, et cetera, there's due diligence to the acquisition program at large. So we will have to figure out how to transition these into programs of record. We will have to do that work. But I don't want to start there because I think there's some quick wins that can get the ball rolling so we can rapidly learn these lessons and then provide a more informed product to the acquisition community when we turn it over. But that's exactly what we're trying to do with the ShadowNet is put some data in our depository. So we say, listen, here's why we want to build this kind of cloud structure. Here's why we want to lease it rather than buy it, because the data supports that we can do it better if we lease it. I'm making that up, but maybe it does. We want to collect the data to support that. So the short answer, yes, we need to pursue all of the avenues to rapidly put data behind us.
Good morning. Akhil Gujral, the Aerospace Corporation. So you talked about the different initiatives that are currently in work and how one program manager working on one initiative may not necessarily know what the other PM's doing. And I can understand why that may be the case. But is there some sort of a construct or some documentation which connects these various initiatives? And what I mean by that is, the multiple formats, the interfaces, the firewalls, the backward compatibility with, say, sensors, et cetera. How do you ensure that you at least define those? So with these various initiatives, you get some common.
Yeah, great question. The first step is acknowledging you have a problem, right? Hi, I'm Chance. I can't manage my data very well. So the short answer is recognition that we need to look across the enterprise. And so you see that we are identifying challenges across the enterprise. Second is the known issue with standards, whether it's data, messaging, interfaces, et cetera. That was really the impetus behind standing up the Air Force's Chief Data Officer. Major General Kim Kreider's been doing that work for over a year now. And my understanding is they plan to publish an Air Force strategy associated with data standards in the coming months. So we're close there. Then it'll be about the discipline to apply those standards as we continue to move forward, and then figure out how we retroactively pull some of our legacy capability into those standards, et cetera. So there is a plan for that, and they're doing good work because of the recognition that that's so foundational. If you see any of my professors out there around the streets, just tell them I did a decent job, whether it's true or not. And I really appreciate the time, and thanks to MITRE and the team for hosting. Thank you.
Thank you so much.